Okay, let's get rolling. So what we're going to do is, I don't know why that just popped up. I don't need it. Okay, we're gonna just start off with a review problem because I know that this is one of the more difficult things to go through in the semester. So at the top of our page, the initial exercise is a review problem of mixture problems. Okay, where we set up, and remember the setup I used was we drew the boxes, filled it in to create our two equations. So what I would like you to do for that exercise, I'm going to give you 2.5 minutes, is at least set up the equations. Okay, that's where I'd like you to take it, and then we can go from there. So go ahead and get started. And if you need me, raise your hand. Right, so the setup I employ doesn't have to be the way that you do it. If you can see how to set this up without any pictures or anything, that is totally great. But this just helps me kind of distribute the information and to think about it. So we got a candy store manager planning to mix some $2 per pound nuts. So I've kept the numbers nice and simple here, and $1 per pound chocolate. And what this person wants is 100 pounds of a mix that's going to be sold for $1.30 a pound. Okay, so we want to know the question we're going to try to answer is how many pounds of each of the nuts and the chocolate are we going to add together. Okay, so the first thing that we do is whether it is a mixture problem involving percents or a mixture problem involving in this case money, we start off the same way. We're gonna label our boxes what they represent. So this is going to be the $2 per pound stuff. This is going to be the $1 per pound stuff, and then I want my result to be $1.30 a pound. And so now the top, what we're going to do is we're going to label with the amount of each. So for both the $2 and the $1, we're not told how much. That's what we're looking for. So what are we going to call these things here? Sure, just whatever your favorite letters are, X and Y, I'm going to use. Those tend to be mine. And so then what are we told we want the amount of the output to be? 100, perfect. And so that gives us our first equation. That's our total amount. The amount of nuts plus the amount of chocolate needs to equal 100 pounds. So there's my first equation. X plus Y equals 100. The second equation in this case is, okay, now how much is each of these things worth? So if I add X pounds of nuts and they're $2 a pound, then this whole box here is worth 2X. If I add Y pounds of chocolate at $1 a pound, then this whole box here is worth 1Y. And then if I have 100 pounds of something that I'm selling at $1.30 a pound, then my result is $130 is what that's worth. So my second equation comes from the cost. And the second equation is the cost of the nuts plus the cost of the chocolate should equal 130 pounds. Or excuse me, $130. And there's my two equations. Now, I'm not trying to minimize that by going through it fairly quick. This is a review problem, but is there a question about this? Okay, anything that is not as clear as I think I'm making it. It's a hard problem. So real quick, let's solve this. I don't know if you had time to solve it or not, but let's go ahead and do this. So I'm just, because of the way it's set up, I'm going to use elimination. You're welcome to use substitution. That is totally fine. It would work really, really well here. I'm going to eliminate the y's. So if I'm going to eliminate the y's, what do I have to multiply which equation by to do this? Yeah, if I'm going to get rid of the y's, so I'm going to multiply one of these equations by -1, but I heard somebody say -2. If you want to eliminate the x's, then you would multiply the top equation by -2. Neither of those is a wrong answer. You got a lot of liberty when you're solving these things, but I'm just going to multiply this top equation by -1 in order to eliminate the y's. That's what I'm choosing to do here. So I'm going to rewrite my equations. The top equation now is -x. And then minus y equals -100. I didn't have to do anything to the bottom equation this time because again, I kept the numbers relatively relaxed on this one. And when I add these two things together, the -x plus the 2x is x. The -y plus y are eliminated. That is the premise of the elimination method. And then -100 plus 130 is 30. So there we go. X is equal to 30. And then just remind me, what do I do with x equals 30 in order to figure out the other value? Plug it in. It doesn't matter which equation. Again, you have choices. I'm just going to go up here. I'm going to use this top equation. I'm going to write the work right next door. So the x value is 30. So this says 30 plus y equals 100. And then I'll subtract 30 from both sides. And that tells me that y is equal to 70. And then whenever you're solving an application problem, I know these are super simple situations. I get it, but we got to start somewhere as we're learning the stuff. Let's just answer the question. The question is how many pounds of each? Okay, well then this tells me x is 30, so that says we're going to mix 30 pounds. For whatever reason, the abbreviation for pounds is LBS. So we're going to mix 30 pounds of nuts with 70 pounds of chocolate. And that's done. Have a test on Monday. Okay, over this unit, which we're going to finish up now. The last two sections, they used to be one section in the old version of the book, so it's not going to, neither of them are going to be super long. But if you have any questions between now and the test, okay, I have my virtual office in the morning. You can email me all weekend. I have office time before your class on Monday. Okay, so I get here at 7:30. My door will be open if anything came up over the weekend of your studying. Okay, so section 4.1, this first page, what we're going to outline is something that I'm assuming you know. It's prerequisite knowledge, but I like to go over it just in case it's a faded memory, or maybe you didn't hang on to it, you don't remember it at all. We're just going to go through real quick the rules for exponents. And then what we're going to do is we're going to get to the part where I'm not assuming you know, and we're going to expand this knowledge a little bit. Okay, so there are basically four big rules of exponents that we're going to go over: the product, the quotient, the power, and the zero rule for exponents. So the product rule refers to what I do when I multiply two things with the same base. So for instance, let's say that I have x to the 7th times x to the 9th. Okay, so notice those two things right there, they have the same base. That is important. I'm going to put a little arrow under that to just draw your attention to it. The product rule does not apply if the bases are different. Does anyone remember what I do now to simplify this when I have two of the same bases that I'm multiplying? What do I do? Add the exponents. Yes, I'm hearing lots of voices. That's great. And so what I get here when I do this is I keep the base the same. You don't change it at all. So it's x. And then you add the exponents. 7 plus 9 is 16. So when you're multiplying your bases, you add the exponents. So I'm just going to write down a couple problems that I want you to do just to kind of refresh your memory about this product rule. So here's the first one. I've got y to the 3rd times y to the 9th times y to the 6th. What is that equal to? The next one is going to be 8 to the 4th power times 8 to the 3rd power. What is that equal to? Actually, I got two more. I've got x times x to the 7th. What is that equal to? And then one last one, p to the 5th times q to the 2nd. What is that equal to? I'm going to give you I have a purpose for each of those problems that we're going to go through. Now let's see how you did. And if you got any questions about this, we are going to be, if you got the product rule nailed down, then when we expand our knowledge in a minute, the product rule doesn't change. Okay, it's going to be the same thing. So I've got y to the 3rd times y to the 9th times y to the 6th. The reason I'm including this problem is just to show that it doesn't matter how many times you multiply your bases. You're just going to keep adding the exponents. So what is the result going to be when I multiply these three things together? Yeah, y to the 18th. 3 plus 9 is 12, plus 6 more is 18. Okay, everybody tracking with me on that? Let me know when you're not, okay? The next one, the reason I gave this, the 8 to the 4th times 8 to the 3rd, is I want to illustrate that the base does not change. A common mistake here is when we do 8 to the 4th times 8 to the 3rd is to change the base to 64. You do not do that. You don't multiply the base. Adding the exponents takes care of that. So my base is going to stay 8, and my exponent is going to be 4 plus 3, or 7. The reason I gave the next problem, x times x to the 7th, is even though it's not written there, what is the exponent on the first x? It's a 1. When the exponent's 1, you don't write it down. It's just implied. But I did fill it in there just so we do the problem. And so then x times x to the 7th, 1 plus 7 is x to the 8th. Then this final problem, p to the 5th times q to the 2nd, I gave again just to reinforce the idea that the bases have to be the same. Are the bases the same on this problem? No, you can't do anything with that. P to the 5th, q to the 2nd is just p to the 5th times q to the 2nd. There's absolutely nothing you can do to that. Okay, I do have one more that we're going to do, and then we're going to move on to the next rule. So this time now I'm just going to have a multiplication problem, but we're going to have different bases that you have to make a choice. So for instance, if I have a to the 2nd, b to the 5th, we just saw that when the bases are different, I can't do anything to that. But now if I multiply it times an a to the 3rd, b to the 6th, I do have some things that I can multiply together. So give that a go, please. All right, so when I multiply these together, I can multiply the a to the second times what? A to the third, yeah, and that gives me a to the fifth power. So I've combined the a's. And the reason I can do this is because there's no addition or subtraction or here. It's all multiplication. So I can multiply together the things that are like. So I have b to the fifth and b to the sixth. So that's b to the 11th, and that's the result of that. So far, are we so good? Okay. All right. So the next rule, again, this is prerequisite knowledge, but I like to review it. It's called the quotient rule. Quotient means to divide, in case you'd forgotten that. So let's say we have the situation x to the seventh divided by x to the third. Anyone remember what we do now when we divide the bases? You do subtract the exponents. That's right, we subtract. When you divide the bases, subtract. Once again, you don't do anything to the base. This is x to the seventh divided by x to the third, so it stays x, the base. And then we subtract. 7 minus 3 is 4. And there we go. That's my quotient rule. I've got 3 examples here for you. If you think of any questions that you need to ask, by all means do it. So the next one is t to the 8th divided by t to the 2nd. What is that equal to? And then we have 3 to the 17th divided by 3 to the 5th. What is that equal to? And then last but not least, we've got x to the 7th, y to the 5th divided by x, y to the 3rd. What is that equal to? So the first one, t to the 8th divided by t to the 2nd, is going to give me what as a result? Perfect. The base stays t, and I subtract the exponents and get 6. I give this next one because I know what our temptation is. We see those 3's and we're dividing, and we want to say 3 divided by 3 is 1. So if you did that, circle this problem so that you remember to review it before the test. My base is going to stay 3, and what is my exponent going to be? Perfect. Love it. And then last but not least, we have a problem with division that's similar to the multiplication. You can only apply the quotient rule when the bases are the same. So x to the 7th divided by x is x to the 6th, and y to the 5th divided by y to the 3rd is y to the 2nd. That's the second of our rules involving exponents. The third one is the power rule. The power rule talks about the situation when I have a power that is raised directly to another power. So if I have x to the 5th, then I'm going to raise the 3rd. Notice I have something raised to a power raised directly to another power. So in this case, again, anybody remember what you do here? Perfect, you multiply. So this is x to the 5th. I've got 3 of them, so that becomes x to the 15th. Yes, for sure. So here's a few examples. Again, I have something to illustrate for each of these. So here's the first one. Let's say that you have x to the 4th raised to the 6th. What is that equal to? The next one, I have 3x squared, x squared y to the 3rd, and we're going to raise that to the 4th power. Be careful with that one. And then last but not least, we have 2x to the 2nd, y to the 4th, and we're raising all of that to the 5th power. What is that equal to? So the first one says x to the fourth. We're raising that to the sixth power. So what's my result there? Yep, x to the 24th. Great job. Now this next one, please make sure you're paying attention. This is the most commonly made mistake on this next test coming up, and I want you to avoid it. Okay, so we have 3, x to the second, y to the third. We're raising that whole thing to the fourth. Okay, so talk me through. What's the first thing I've got to write down? Okay, 3x. Okay, so I'm going to call timeout. Okay, so you're doing the thing that I expected, and that's totally okay. So this is an opportunity to learn. We have to remember here that each of these 3 things, because they're being multiplied, they have their own power. We have the y has the power 3, the x is the power 2, and the 3, even though it's not written, what's the power on the 3? 1. So when I go through and I apply the power rule, you have to remember to apply the power rule to each of the factors. So that means my 3 is not just going to be 3. It's going to be 3 to the 1 times 4, or 4th power. Okay? So if you missed that, forgive yourself. It's okay. It's a common mistake, but learn. Okay, circle this problem. Remember, because I'm going to put 1 problem or 2 problems on the test just like this to see if you're listening. Okay. The next one, x to the 2 times 4. I've got x to the 8th. And then y to the 3 times 4 is 12. Now, at this point, if you leave the problem like this on the test, I'm 100% happy. You'll get full credit. I think my math lab, they're going to want you to use your calculator to evaluate this. So in your calculator, you're going to go 3 to the 4th, or you're going to multiply 3 times 3 times 3 times 3, and you're going to get 81. But again, on the test, that is not a required step. If you do not know how to do exponents on your calculator before you leave here, bring your calculator up. I'll show you. There's generally 2 types of calculators that you all have, and it's really easy to do exponents, but maybe you just haven't done it before. Okay, the other one, just to reinforce this, now I've got 2x to the second, y to the 4th. I'm raising all of that to the 5th, so help me out. I'm going to have 2 raised to what power? The 5th, yep, because there's a 1 there. It's implied. And then I'm going to have x raised to what power? Yes. And then I'm going to have y raised to the, perfect. And then this is fine for me on the test, but again, 2 to the 5th, if you pop that into your calculator, 2 times 2 times 2 times 2 times 2, that's 32, x to the 10th over y to the 20th. All right, the last of our review rules is the 0 exponent rule. And the 0 exponent rule just simply says if you have something raised to the 0 power, okay, this is another one that sometimes we stumble over. Anything raised to the 0 power is going to be 1, okay, not 0. Again, very common mistake. So if that's what you were thinking, forgive yourself, but it's time to learn. So anything to the 0 power is 1. Now, every semester, I always get the question of why is that? Why isn't it 0? That's a great question. Math is, remember, about patterns. So let's do this. I'm going to start with 7 to the 3rd. If you had your calculator, 7 to the 3rd, 7 times 7 times 7, I think, is 343. Well, let's go down a notch. 7 to the 2nd, 7 times 7. What's 7 times 7? 49. Let's go down one more notch. 7 to the 1st. 7 to the 1st is just 7. Okay, so the next one in line, the next one down will be 7 to the 0. Now, before we identify that, let's see what the pattern is. To go from here to here, to go from 343 to 49, what do you do arithmetically? You divide by 7. Okay. To get from 49 to 7, what do? You divide by 7. And so to get to my next, to get to the answer to what's 7 to the 0, you're going to divide by 7. And 7 divided by 7 is 1. Okay, so that's a quick way to remember. If you're like unsure on the test, I know we did something in class, just follow the pattern down the line until you get to anything to the 0 power is 1. So real quick, here is your lone example to do for this. Let's say that I give you, and I'm going to, there's a problem just like this on the test. I want this to be nice and quick and easy points for you. Let's say we have negative 12,432.7 raised to the 0 power. And I know all the time you're taking is because you're writing down the crazy number I wrote. But what is negative 12,432.7 to the 0 power? It's going to be 1. Positive 1. Because any number in here that I raise to the 0 power is going to be 1. All right, well done. These properties are not going to change. At the top of the next page, though, I'm going to introduce the new concept of the day. Okay, so this stuff right here does not change. We're going to use this, but here is the new bit of information for the day. It is, what does it mean if I see this? So here is the example. Let's say I have x to the 5th power divided by x to the 9th power. And I told you just a moment ago, the quotient rule says that when we divide our bases, we subtract. Okay, so here we go. What is 5 minus 9? What do you get? 5 minus 9 is what? Negative 4. Okay, so this is the situation I am not assuming you have seen. Maybe you have and you know what's coming up. That is great. But this is what we're learning today. What does a negative exponent tell me? Okay, well, let me do this problem a different way to show you what physically is happening with this negative exponent. X to the 5th power means I have x times x times x 5 times. Divided by x to the 9th means I have x times x how many times? Yep, 5, 6, 7, 8, a lot of x's. Okay, I'm going to give you a moment, if you're writing down, to write all that down, because this is my illustration to show you what physically x to the negative 4th, what does a negative exponent, what is it communicating to us? So now, by division, I can do a little canceling here. I can cancel pairs of x's. So I can cancel this first one with that one. I can cancel the second one with the second one here, and the third one with the third one here, the fourth one with the fourth one here, and the 5th one with that 5th one. Okay, just doing a little canceling. After I've done all the canceling, how many x's are left? 4. But here's the more important question. Where are those 4 x's? They're in the denominator. Okay, so this is, since I've done my canceling, I have a 1 in the numerator, and then I have 1, 2, 3, 4. I have x to the 4th in the denominator. And so that shows me what a negative exponent is communicating. Up here, when I did x to the 5th divided by x to the 9th, and I subtracted 5 minus 9 gave me negative 4, what that negative exponent tells you is that the base is in the wrong place. Okay, this x to the negative 4, I then rewrite as 1 over x to the positive 4. Anytime you see a negative exponent, it means you got to put the base in the other part of the fraction. So if you have a negative exponent in the denominator, you move it up. If you have a negative exponent in the top, like this one right here, then you move it to the bottom. So here's just a few problems real quick, just to illustrate this and to help you work through it and practice. So I just want you to rewrite these in the simplified way, which means with a positive exponent. So first one, y to the negative 6. Just write that with a positive exponent. 5 to the negative 2. Rewrite that with a positive. This one's going to be a fun one. 3p to the negative 2. Make sure you understand what the exponent is applying to in that problem. 1 over y to the negative 7. And then this last one, I've got a to the negative 3 over b to the negative 2. I'll give you a moment to resolve each of those and write them with positive exponents. All right, so let's see how you did on each of these. If you have a question, bring it up so that we're clear, so that we can go on and finish the rest of this section. So here we go. Y to the negative 6. How do I rewrite that with positive exponents? 1 over y to the 6th. Fantastic. Well done. 5 to the negative 2. What's that? 1 over 5 to the 2nd. And again, you can leave it like that for me. But 5 to the 2nd, 5 times 5 is 25, so that's 1 over 25. Now this next one, be careful. What is the negative 2 the exponent of? The p, okay? There's no parentheses around that. So when you resolve this, what is the exponent on the 3? It's a 1. So the 3 stays where it is, and then the p to the negative 2 becomes p squared in the bottom. Now that is, I'm going to contrast that. Some of you may have done this, and I understand. That's why I give these examples. I've thought this through. Maybe you thought it was 3p, but then in parentheses, negative 2. Now that's different, because now what is the negative exponent? What is it applying to? The parentheses, right? Whatever's in the parentheses. So now on that one, you would say that's 1 over 3p to the 2nd, and you could resolve it further from there, but I'm kind of out of room. The next one, 1 over y to the negative 7. What is that with a positive exponent? Y to the 7th. Yeah, just up top. Perfect. Well done. And then last but not least, I've got an a to the negative 3rd in the top, a b to the negative 2nd in the bottom. So what is this new fraction going to look like with positive exponents? Well said. Beautiful. B squared in the top, we move that negative exponent up, and then the one that's in the top, we move to the bottom. Okay, everybody tracking with me on how this is working? We doing okay? All right, so now what we're going to do is we're going to take that little bit of new knowledge, and we're just going to combine it with what we talked about earlier. The product, the quotient, the power rule, okay? They all work the same way. Product rule, you add the exponents. Quotient rule, you quotient rule, you subtract the exponents. Power rule, you apply them. And we're just going to apply them in this situation here. So I'm going to do this first one, and then we're just going to go one at a time through these problems. So the first one of these exercises says, I have x to the negative 8 times x to the 4th times x to the 6th. This is a product rule problem. I'm going to add the exponents. Don't be shy about using your calculator if you want to, okay? No one's expecting you to be able to add up a whole series of numbers in your head. You can if you want. Negative 8 plus 4 is, anybody know? Negative 8 plus 4 is negative 4, yep. And then that negative 4 plus 6 is 2. There you go, x to the 2nd. Done. The only thing you have to remember is if you do a problem and you end up with a negative exponent, you have to make it positive at the end. Okay, that's considered simplified in math land. Okay. So go ahead and try the next one right next door. Y to the 5th times y to the negative 9th. And what do you get when you take y to the 5th times y to the negative 9th? What's 5 plus negative 9? Negative 4. Okay. So we have y to the negative 4th. If you got that, you are doing fantastic, but you're not done. Okay, I got one more step. Since that result has a negative exponent, I've got to make that 1 over y to the 4th. The next problem is a quotient rule problem. K to the 7th divided by k to the 12th. Please go ahead and do that. So the quotient rule from the front page, when I am dividing my bases, what do I do with those exponents? You subtract them. Yeah. So this is going to be k to the 7 minus 12. And when you put 7 minus 12 in your calculator, what do you get? -5. Again, what that tells me is there were more k's in the bottom of the fraction. And so when I write my answer, I'm going to write 1 over k to the 5th. You might be saying, hey, Perkster, I saw that right away. Do I have to write all that down? Can I just write 1 over k to the 5th? Yeah, sure. Once you get to that place where it's pretty obvious, for sure. Yeah, simplify a little bit. Okay, the next one, another quotient rule problem. Go ahead and do it. All right, there's actually two ways you can do this problem. I'm not going to do all the quotient rule problems both ways, but I'll do this one both ways in case you find you're more comfortable with one of the ways versus the other. So here's the first way. Okay, way one. This is the way I would do it because it's just straightforward. What I would just do is apply the quotient rule. Okay, and so I have x to the, and I'm going to write this out since we've got negatives. I've got x to the -8 is the top exponent, minus, and then -5 is the bottom exponent. So I have -8 minus -5. Well, -8 minus -5 is -8 plus 5, which is -3. And I'll rewrite my answer as 1 over x to the 3rd. So that's the way I would do it. I would just apply the quotient rule and subtract those exponents, being real careful of the negatives. That's kind of the trick there. Now, others, okay, other instructors, other students might say this, because I get this question every semester. Hey, Perkster, before I do this problem, can I resolve the negative exponents first? Okay, I would be more comfortable that way. And I'd say, sure, that's great. So if you want to, what you can do is you can say that x to the -8 goes to the bottom, and that x to the -5 goes to the top. So I've not changed anything's truth value. I've done what the negative exponents have told me. And now the quotient rule says 5 minus 8 is -3, and I have 1 over x to the 3rd. So notice we get the same thing either way. So when I do the problem, I'm going to do the straight quotient rule. But if you want to resolve your negative exponents first, that's totally a fine tactic to use. Okay, so go ahead. Next one, 5 to the 4th divided by 5 to the -3rd. All right, once again, I'm just going to use the quotient rule because it's a quotient. But if you took the 5 to the -3rd and brought it up top, then it becomes a product rule problem. And that's a perfectly great way to do it. Okay, either way, we're going to get the same thing. So I have 5, and then again, I'm going to write this out because I've got negatives I'm dealing with. I've got 4 is the exponent in the top, minus, and then -3 is the exponent in the bottom. And so 4 minus -3 is the same thing as 4 plus 3, which is 7, 5 to the 7th power, which is a large number. I'm not going to bother multiplying that out. That's the whole purpose of exponents, is to write large numbers in a smaller area. All right, one more quotient rule, just because it tends to be the one that confounds people the most. Do a to the -3rd divided by a to the 6th. right, so one more time, I'm going to go ahead and apply the quotient rule. You can move that -3 down to the bottom. So I'm going to have a to the -3. That's the top exponent minus the 6 is the bottom exponent. And so -3 minus 6 is -9. And a to the -9th is 1 over a to the 9th power. So all of that to say is when you're applying the quotient rule and you have negative exponents, just be real careful with your subtraction. Okay, subtracting negatives and things like that. Next problem is a power rule problem. Okay, power rule from the front. So 2 to the -3rd raised to the -5th. Take care of that, please. Power rule from the front part of the sheet says just multiply those exponents. So that does not change. So I have 2 to the -3 raised to the -5th. So -3 times -5 is +15. Okay, going to be a large number. I'm just going to leave it as 2 to the +15th. Do the next one. Okay, remembering that thing from the front page that I said to be careful of, that 5 has an exponent on it. Okay, so be careful. All right, so let's see how you did on this first one. And if you made a mistake, you'll get your chance to you'll make up for it here in the coming problems. So I've got 5x to the 4th, y to the -3rd, all raised to the -2nd. So first, 5. When I apply the product rule, excuse me, when I apply the power rule, what is the exponent on the 5 going to be? Perfect, excellent job. And then when I apply the power rule, the exponent on the x is going to be? Yep, for sure. And then the exponent on the y is going to be? Perfect, yes. And so now I just got to resolve those negatives. So if you didn't do this part, that's okay. We're learning as we go here. I'm going to draw a fraction bar. Where's the 5 to the -2 going to go? The top or the bottom? Bottom. So it becomes 5 to the 2nd or 25. I'm not going to rewrite it, but if you want to, you can. How about the x to the -8th? Where is it going to be found? Bottom, x to the 8th. And then the y to the 6th, the exponent's already positive, so it stays right where it is, y to the 6th. All right, next one, another power rule problem. X over 2, all of that raised to the -4th power. So let's apply the power rule first. So that means in my numerator, x, what's the power on the x going to be? Yep, yes, sir. Appreciate it. What's the power on the 2 going to be? Yep, same thing. So I've got two things with negative exponents. So the only other thing to do here is to resolve those. So the x to the -4, that goes to the bottom, becomes x to the 4th. The 2 to the -4 goes to the top, becomes 2 to the 4th, or you can write that as 16 if you prefer, but I'm going to just leave it just like it is. The next one, as we go to the right, is very similar to the problem right above it that we did. So again, don't forget about that 6 as you're going through and doing the problem. All right, here we go. One factor at a time. So as we go through, we apply the power rule. It's going to be 6, and the 6 is going to have power -4 on it. And then it's going to be y. The y is going to have power -2 times -4 or 8. And then it's going to be y in the bottom, and then 5 times -4 is -20. Now you might have a question, hey, Perkster, before I did that, I took care of those y's and I combined them using the quotient rule. Could I do that first? And the answer is yes. You could definitely do that first. The order is not going to mess you up here. So I'm going to take care of the y's right now. So I have 6 to the -4th. We'll take care of that in a minute. Then I have y to the 8 minus -20. 8 minus -20 is 8 plus 20 or 28. And so my end result is going to be the y to the 28th is going to stay up top, and then the 6 to the 4th is going to go to the bottom, and that's a large number, so I'm just going to leave it as it is. So you see with the exponents, you have some liberty. If you had said y to the -2, -2 minus 5, that's -7 right there, and you've done that straight away, that's fine. Okay, you're going to end up in the same place I did. All right, we're almost done with this section. 2 more problems. So down at the bottom, the one on the left, we've got x to the 5th, y to the -2 in the top, and then x to the 8th, y to the -3 in the denominator. Give that your best shot. So this problem is just the quotient rule twice. So the first one, I've got x to the 5 minus 8. 5 minus 8 is -3. Again, if you moved those y's around, like I said before, that is perfectly fine. I'm just going to attack the problem the way it is right now. And so I have -2 minus -3. I'll write that down just because I don't want to assume everybody's following along. So -2 minus -3. So I have x to the -3 and then y. -2 minus -3 is -2 plus 3 or 1. And so the y stays in the top because it has a positive exponent. The x goes to the denominator because it has a negative exponent. All right, last problem for this section. And I know you look at that problem, you're like, oh my goodness, there's so much to do there. But it's really not as bad as it might look if you just take a breath, and we're going to do it in stages. So here's what I want you to do, and then I want you to come to a complete stop. All we have here is we have 2 of what we just did up in the problem right above it. So first thing I want you to do is I want you to apply the power rule to both of those things and then stop. So just raise the first one to the third power, the second one to the -2 power, and then stop. We'll go from there together. All right, so power rule. Let's do this, and then I'll give you your next instruction. So this is just what we did in the problem right above. So I've got 2 raised to the third power. Don't forget that. Then I have x to the 2 times 3 or 6th power, and then y to the 2 times 3 or 6th power. So that's the first parentheses that I've applied the power rule to. And then times, and then the second parentheses, I've got 5 raised to the -2 power. X to the -2 times -2, that's +4 power. And then I have y to the 4 times -2 or -8 power. So all I did there was the power rule, took care of that. And now here's the next thing I want you to do. I noticed that I've got x's that I can combine, and I've got y's that I can combine. So I would like you to do that and make this all one fraction. And then the last thing we'll do, and we'll do it together, is we'll take care of any negative exponents. All right, so here's what I meant, just in case you're having trouble following my instructions. So I've got 2 to the third. There's nothing to do with that right now. The x to the 6th times x to the 4th. What's x to the 6th times x to the 4th give me? Yep. And then I have 5 to the -2. We'll take care of that in a moment. And then in the denominator, I have y to the 6th times y to the -8th. Y to the 6th times y to the -8th. What does that give me? Perfection. Great job. And now all I'm going to do is I'm going to resolve any negative exponents, and I'm going to be done with the problem. So here's my fraction bar. The 2 to the third, that's a positive exponent. So 2 to the third is 2 times 2 times 2, that's 8. I'll just write that right there. The x to the 10th, that's a positive exponent. So we'll leave that right there, x to the 10th. The 5 to the -2, well, that's a negative exponent. So I'm going to move that to the bottom, and it becomes 5 squared, or 25 in the bottom. And then y to the -2, that's going to go to the top and become y to the 2nd. And there we go. So that one had a couple more steps, but it's just applying all those rules that we've gone through and had done in the single step problems.